We're going to talk about the input file of the Gaussian and also about a few other things in the computational chemistry. Okay, the first thing is you should know that what kind of Gaussian, for example, we're going to write in Gaussian and input file. Input file. What is in the input file of the Gaussian? We're going to study about that. The Gaussian, as we studied before, a lot of things. Maybe you know about this. We talked about there are two kind of files. One is called input file, and the second one is output file. So you know that the input file is the file which you make. You make a structure, a guess structure, and then you give it to the system, to the Gaussian. And then the Gaussian do calculations and it tells you that is it the right one or not. What is in the input file we're going to talk about, and then what the system does with it, then what the Gaussian does with it. But then what happens during the calculations and what happens to those files. We're going to talk about that. Okay, the first thing is the input file. You should know that the input file, we have three main parts. The first part is, we call it as link 0 command. What is in the link 0 command? You should know that in the link 0 command, the first thing you take is chk file. We call it a checkpoint file. One checkpoint file. So it starts with this the percent sign. The percent sign chk is equal to, then I don't know, like you want to take the water or you want to take the hydrogen or whatever it is. For example, you took it H2O underscore scan .chk. So this is the first point you should know. And then the second in the link 0 command is the memory. Like the memory you want to set in here. So what is that memory? That memory is in 6MW or GB or whatever that is. And the third one is nproc, number of processors. Nproc means number of processors. How many processors do you want the system to use for your calculations? Keep remember, these first you set the memory for the calculation and then you set the processors for the calculation, that how many processors do you want the system to use. For example, if you want to set one processor, it will use one processor. If two, then two, three to three. Okay, so the first one, these three, which start with the hash sign, with the percent sign, it is called what? It is called link 0 command. Okay, did you check is it online on the Facebook or not? Wait. Okay, thank you. जी जी okay, and then after this with the hash, when it starts with the hash, we call it, this is the link 0 command, and then we call it the route, rout. You know about the route, check it, is it online in the Facebook? We call it, first is the link 0 command and this is the route line. This line is called line. It starts with the hash. Sometimes there is a P, but this is optional. Sometimes it is present or sometimes it is not present. Yes, this computational chemistry. What is the next one? Is slash method slash basis set, and we call it level of theory. With the method and basis set in the papers, if you study the computational chemistry papers, you will see a word, and that word is level of theory. This level of theory means that there is a method slash the basis set. For example, maybe you will have seen HF, which is your method, slash 321G, this is your basis set. Okay, so this is the first one is the method, and then there's a basis set, which is called, both of these are called the what? Yes. Then there is another, the job. Which job do you want to run? Like you want to run optimization, you will write OPT. You want to run you want to run the optimization. When you want to run optimization, you will write instead of it frequency, this FAREQ. If you want to run something else, you have to write that job word in here, the term of that job. For the optimization, we write OPT. For frequency, we write FREQ, and there are different, so we can write those different for those. Okay. Yeah, it works. Yes. Then there is another, the job. Which job? Okay. Now, the last one is, maybe you all have seen that there is GEOM is equal to connectivity. This word, this is optional. Then you will see there is a blank line, blank. Then there is a title. You have to write the title of this input file we want to calculate. Then there is another blank line. You will see there is that blank line. Rimsha and Atya, this is for you. And then there is charge and multiplicity, both. You have to write the charge and multiplicity. At the end, you will find in here the number of atoms present in your structure, and then the coordinates. There are two kind of coordinates. Coordinates mean the structure which is present, how the structure is in x-axis, y-axis, or z-axis. In x, for example, I'm going to tell you that how to write these coordinates. So you just see the first thing, this is the input file. The first thing is the link 0 command, which contains the %chk is equal to whatever the name of that your file is in .chk. Percent memory is equal to whatever the memory you want to give. Percent and proc, any number of processors, is equal to the number of processors you want to give. Then it starts with the hashtag #p method slash basis set optimization, whatever you want to study. And then if you see, there is a blank line, the title, blank line, charge and multiplicity, and then the coordinates. The coordinates is how many coordinates are present in there? Two types of coordinates are present in there. One is called the Cartesian coordinate. You know the Cartesian coordinates mean, when there is Cartesian, it means you want to talk about the x, y, z. What? You want to talk about what? X, y, and z. That is called coordinates. Which coordinates? Cartesian coordinates. For example, there is H2O. See in here. First I want to take the HO. So when I want to take the O, I'll write the O. Now consider this is on the 0. What? Consider this is on the very 0 part. So when the 0, we will write on the x-axis 0, the y-axis 0, the z-axis 0. Like we will say, then this is not on the x-axis, y-axis, and z-axis. And the 3, for example, this is the x-axis, you see, this is the y-axis, and then there is the z-axis. Then x is called plus x, but in here this is called minus x. This is called plus y, but in here this is called minus y, the opposite one. This is called plus z, but the opposite one is called minus z. Now this O is present in here, for example. So this is 0, 0, and 0. Oxygen is 0, 0, 0. Now I'm going to take the hydrogen number 1. I'll write hydrogen in here. And in the hydrogen, and the x-axis, this is minus x, minus 1. For example, the bond length is minus 1, so minus 1. On the y-axis, this is what? See now, for example, on the upper side this is plus y, but on the lower side this is minus y. So this will be minus 1 in here, and then you see on the z-axis there is no z-axis, we will write the 0 again. Now let's go towards this hydrogen. For example, this hydrogen is present in here, this is on the plus 1 because this is on this side, and you see this is the plus x, so this is the plus 1, this the bond length is 1, so we will write it's plus 1. On the y-axis, you see, yeah, this is on the y, but this is lower than the 0, this will be minus 1, and the z-axis there is no 0, we will write it as 0. So this is what your coordinates are. These are called Cartesian coordinates. So you can see, you can find your input file in this. You should remember the names of this length 0 command, route line. This is route line. This is title, blank, and then charge and multiplicity, and then coordinates. Okay, so these are the things, the main things. The first one is length 0 command and route line, then the title and charge and multiplicity, and the last one is this one. Okay. Okay. So this is what about the Gaussian input file. This is the Gaussian input file, and then there are geometry specifications, and when we study about the geometry specifications, geometry specifications mean that how can you specify the geometry, how can you just talk about the geometry, how can you give calculations to the system. So we have two geometry optimization specification, geometry specifications, two types. Number one, Cartesian coordinates, and the second one is Z matrix. Okay, in the Cartesian coordinates, these are the Cartesian coordinates. In here you see, in the x-axis, y-axis, and z-axis, the atom is present in the x-axis, y-axis, or z-axis. Another atom you want to talk about, that is x-axis, y-axis, or z-axis. Where is it present? That is called That is called the Cartesian coordinates, which is present on the x, y, and z axis, and these three axes. That is called Cartesian coordinates. Okay, these you see -1, 1, 1, etc. These are in angstrom. The second thing is angstrom. We're gonna calculate these in angstrom. And these are the most convenient because most molecular building program will output Cartesian coordinates. For example, you have these coordinates and then you give to the system, it will calculate and it will just change these coordinates, these Cartesian coordinates. So they will change these coordinates. You can just see it in there. Okay. Then Z matrix, and the Z matrix, this is the second one, is the Z matrix. In the Z matrix, these are also called the Z matrix. This is also called what? Internal coordinates. Internal coordinates. Mean they also called the Z matrix coordinates are also called internal coordinates. Okay. Ma'am Zoya? She's gone. Okay. So these are or Z matrix coordinates. Okay. Okay, so this is all about the, okay, sorry. So this is also called, what? This is also called the internal coordinates. Why, what happened? Thank you, Khanullah Mushfiq, I guess, whatever the name is. Okay, in the Z matrix, which is also called the what? I think the internet is slow. Yeah, check it and then tell me.